Have you ever wondered what really stays the same in this constant changing of the world? Well, I know I have, so I'm just going to tell you, I went on a quest to search for what really stays the same, or what really remained constant. Oh, it was a really long quest. I Googled it, I searched it up, I looked at textbooks. I'm just going to save you a ton of time. I'm just going to tell you what really is. And enthalpy is basically, and the process of changing, or what really stays the same in this world, is called enthalpy. What enthalpy is the changing of heat or transformation of heat flow from one system to the surrounding. So something that I want to touch up with you guys real quick is that the energy change associated with the chemical reaction is called the enthalpy of a reaction, and it's abbreviated with H. So, and H is basically another sign for heat. So delta H is another word for change of heat. And you guys really need to understand this before you actually start anything in this assessment, or actually in this project of Chapter 5, ThermoChemistry. There's one thing that I really want you guys to know about enthalpy. Enthalpy is simply another word for energy. So get that into your head. Enthalpy is energy. Enthalpy is energy. So now that you already know that, all right, so now let's get back to, there's two types of enthalpy. No, not mean two types, there's two ways to process or understand enthalpy. The first one is, imagine the system. Everything that's inside here is called the system. Like, you see the blue box, that's a system. And everything outside the blue box is called surrounding. Now, depending on the specific molecule or the reaction that occurs, heat could enter the system, or heat could leave the system. All right, depending on if it leaves or enters the system, you determine what it is. All right, so now that, since heat, don't think about the system leaving heat. Think about the surrounding entering or exiting. So to think about that, since heat is entering the system, that means that the change of H within the system is greater than 0. The change of H is the change in temperature of final minus initial. So if the final is greater than 0, that means that heat entering the system, and the opposite can be taken effect. If heat is leaving the system, that means heat of the system is less than 0, and that would be endothermic. Endothermic would be the first one, and exothermic would be the second one. Now let's talk about that real quick. All right, so now let's talk about that real quick. Now I'm just gonna give you guys real quick quiz over this. All right, since we just went over it. All right, if heat is greater than 0, what is the system doing? Don't think of what the surroundings doing. Think about what the system is actually doing. All right, since change of H is greater than 0, it means that the system is absorbing the heat. All right, and then if the system is losing heat because it's less than 0, that means the system is losing heat. So that's basically it. That's all you really need to know about it. Now that I've given you guys everything you need to know on how to do enthalpy, let's start out with an example of actually how to do enthalpy. So the first question is, calculate the enthalpy of the following reactions. The reaction is this one, this one, this one, and this one. And that's the question. This is what you guys want to get to. This is the formula you guys want to get to. This is the destination that you want to get to calculate the enthalpy. All right, so the first steps that you guys need, and this is also the given. There's 3 equations that was given. The first one, the second one, and the third one. And the desired result, like I said multiple times, is this equation right here. This equation is the one you guys really want and need to calculate the enthalpy. And remember, enthalpy is another word for energy. So you guys want to use that again. So the first thing, so the desired result is, I'm just going to write it down right here real quick, is CS2 plus 3O22 CO2 plus 2SO2. Alright, as you guys can tell, what you guys really knew is that you see how that CO2 is already on this side as well as here. So that means for equation 1, you don't really need to do anything to the equation at all because it stays the same. Alright, because you guys want to get this to be the same. Okay, so for the next equation, for equation 2, you can tell that we need 2 of the SO2, and on equation 2 we only have 1. So that tells us the best way to get 2 of something is multiplying it by 2. So, and again, this is basically algebra. If you multiply something by 2, you have to multiply the whole thing by 2. And it would be like this. So there will be 2 SO2, 2 CO2, and then 2 SO4. 2 sulfur. Alright. So now, and now that's basically it. So now for number 3, the equation 3, what you need to know is that you can tell that CS2 is on the right side of the equation. And if CS2 is on the right side of the equation and CS2 for what our destination is on the left side, what we need to do is flip the equation. Alright, so now they also gave us the change of the delta H. They gave us the change of heat for each equation. The first one is 393.5, the second one is 297.8, and the last one is 103.2, and the first two are negative while the third one is positive. And since we flipped the equation, it basically means we had subtracted it and added. So that means the change of H, we changed this to negative 103.2 rather than positive that it was given because we flipped the equation. And let's go back to 2. You know how we add everything to 2, and how said for algebra, by multiplying everything to 2, you also multiply the change of heat by 2 as well. When we actually solve it or find the solution, I'm just going to go over the step one more time. For equation 1, leave the equation untouched because you want the CO2 to be on the right side of the equation because it's also on the right side for the solution or the final destination. And for number 2, you want to multiply the second equation by 2 because you want to cancel out the 2 from over here as well as make it so it's 2 SO2 over here. And again, to do that, you have to multiply the whole thing by 2. And to multiply the whole thing by 2, you need to multiply the change of H by 2 as well. So that would change the delta H to another different number that we can get to later. And number 3, you want to flip the third equation because you want the CS2 to be on the left side of the equation and not the right, which it is because we could tell that it's down here as well. And to do that, what we really need to do, what would happen is that this would turn from a positive to a negative because we flipped it. It's basically the derivative. Now what we need, so now that's basically it. Now all you guys really need to do to solve for this would be just add these 3 up, the change of H. The first one is negative 393.5 kilojoules per mole. Add 2 times negative 298 kilojoules per mole plus negative 103.2 kilojoules per mole. And the final answer with my trusty calculator would be negative 1922.3 kilojoules per mole. Alright, since I told you multiple times that enthalpy is energy is usually measured in kilojoules per mole. So the final answer would be negative 1092.3 kilojoules per mole. And that's basically your answer and how you do enthalpy.
Right. Now that I have shown you everything you need to know about enthalpy, I'm going to tell you one main principle of enthalpy that you really need to know. And that main principle of enthalpy is called Hess's law. And what Hess's law says
that heat evolves or absorbed in a chemical process. And basically what a chemical process is like a transformation or a reaction of a chemical from one place to another. And this chemical process takes place in several other steps. Now that you have learned about the diagram as well as the energy levels and how you add them together, I'm going to give you an example of how you actually calculate energy level diagram as well as Hess laws for enthalpy. So in a question there's a givens and it tells you the information that you really need to know. So the information that they tell you is that CH4 plus 2 oxygen equals CO2 plus 2 H2O. So, and this is the equation, the top one and the bottom one. So you simply just have to do the same thing as energy level diagram for A plus B equals AB and the same as here. So the question they want to ask is calculate the enthalpy of the reaction. So since there's CH4 over here and CO2 and the same goes on this side and there's 2 here, you could cross out the two water molecule from this side and 2 from this side, because it's from the left and the right side. And now you just have to bring everything down. So the CH4 goes down, the 2O2 goes down, as well as this carbon dioxide, as well as the water molecule going down. So this is also given. So since all you did was add the two together, since you did this, all you do is add the two molecules together and the two equations together. All you simply need to do is add the delta H, which is 890 and negative 890 and positive 88. So all you really need to do for that would be just add change of A for equation A, change of A for equation A, which is negative 890, plus change of A for equation B, which is 88. And both of these are in kilojoules per mole. Kilojoules per mole. So just simply add together. Change of A for the first equation is negative 890 kilojoules per mole, and the second equation is 88 kilojoules per mole. And to get to the final destination, all you simply need to do is add the two. Alright, since you add the two, it's negative 890 and positive 88. So just bring it down, add it, and your final answer should be negative 802 kilojoules per mole. And again, we're talking about energy, so energy usually is and always will be in kilojoules per mole. If you learn about thermochemistry from enthalpy and Hess's law, what you really need to know that go on, or a process that you need to know for enthalpy as well as Hess's law, is learning about entropy. Entropy is basically enthalpy, but there's some changes. And I'll give you guys a link over to another video that will explain entropy. Any questions that you guys really need to ask Mr. Glass, all you guys really need to do is comment your questions down below, and Mr. Glad will gladly answer all questions that you guys need.